Hi, welcome to my MATT assignment. This video will go through the lab setup as well as the static and dynamic malware analysis. For our lab setup, we have two VMs installed on our VMware workstation. The first one being IM Workstation, which is a Windows 8 OS, and RAM NUC 6. Both of these are configured to be host-only network so that they are isolated from the host and any malware that's run on it will not affect the host machine. For basic and static dynamic malware analysis, we'll only be using the IEM workstation. Now, the first thing that we will do when performing basic static analysis is opening virus total. Now, by opening our virus right here, called Scarab Ransomware UPX, into virus total, we can see that the 45 security scans from different software has shown that it's a Trojan ransomware type of malware, such as here ransom scarab, ransom creep, and Trojan, etc. So off the bat, we can assume that it is a ransomware. Next, we'll be opening up PID to check if the malware is packed or unpacked. As we can see here, the malware has been packed by UPX1. So now to unpack it, we'll be opening up our command line tool. Now the first thing we'll do is head to the directory desktop where our malware is located at. Then we'll type in the code upx-d-o followed by the file name that we want to output to. In this case, I'll name it output1.exe. Then we'll type in the name of our malware, Scarab ransomware upx.exe. And as we can see here, the file has been successfully unpacked using UPX into a file called output1. To check if our malware has been unpacked, one way to do it will be using WinMD5. Opening WinMD5, we can put both our output1 and Scarab ransomware into it to obtain the hash as well as the size of the file. As you can see here, output1.exe is way bigger than Scarab ransomware, thus showing that it has been unpacked successfully, as unpacked malwares tend to be bigger in size. Next, we'll be using File Analyzer to show us the different information about the malware. As you can see here, our malware output1.exe has been opened with File Analyzer. Firstly, checking the version tab, we can see a company name DataArt as well as the original file name where_million. This shows us that the original file name of this file is called where_million, and the software used to create this malware is a software that is made by this company called DataArt. Next, heading to the PE header tab, we can see the date and time of when the malware has been created. As we can see, the malware was created in 18th of June 2018, or for our local time 19th of June. This is still a relatively new malware, although old enough that it has been patched. Moving on to the compatibility, we can see the different Windows OS versions that this malware can run on. It can run on things like Windows XP, Windows 2003, Windows 98. However, it cannot run on our workstation right here, which is Windows 8. as in it cannot run properly, but it still runs. Now next we'll open CFF Explorer, which is a software that contains many different tools to help in malware analysis. Over here, we can again see things like data hardware million, where we already saw before, and we can see the different DLLs imports that this malware has in the dependency walker functions of it. The important things that we will take note of are things like kernel32 and adverpy32.dll. Heading to the import directory, we can take a look at the things inside kernel32 that are important to look at. Now the noteworthy things inside kernel32 will be things such as things like read and write file. It shows that this malware creates a new files that can be placed inside the desk. Yeah, it can be placed inside the system. Other important thing here will also be things like enter critical section, leave critical section, and delete critical section, and initialize critical section. A critical section is the part of a program that accesses shared resources. So these DLL imports, these functions are functions that affects the critical section. Only when a process is in its critical section can it be in a position to disrupt other process. This critical section also provides synchronization similar to that of a mutex object. So the malware could be using this to create things like a mutex, and also to affect the critical section and disrupt other processes as it is a ransomware. The next DLL will be taking a look at is adverpy32.dll. Now the important things to take note here are the many different registry key functions here that can edit registries. This shows that there's a high chance that this malware uses this DLL import to modify the registry keys. The next important thing in this malware will be in user32.dll. When we scroll down to find this get capture, this function is used to retrieve a handle to the window that has captured the mouse input. So this may be a sign that the malware performs certain mouse keylogger feature. Now closing CFF Explorer and heading on to Dependency Walker to cross-check whether CFF Explorer has failed to capture certain DLLs. There is one important DLL that we can see inside Dependency Walker. When we scroll down adverpy32.dll, we can see an important DLL called cryptsp.dll. As you can see, all these functions right here are used to encrypt data. This is a very clear sign that our malware is a ransomware and uses these functions right here to encrypt data and hold the user's encrypted data as hostage for money that they have to send over to the attacker. These are all the important DLLs inside our malware. Next, we'll be performing string analysis using bin tags. The purpose of string analysis is to see important part of the malware such as the file, reference file name, URLs, domain names, IP address, and so on and so forth. So opening bin tags, there's a few important things that we can find. The first would be these few things here. Things like open event A, open SC manager. On top of that, there's also things like impersonally logon user A, which shows that the malware could be impersonating the user's permission so that it's able to modify the registry keys inside the host machine. As we can see here, these are the many registry key functions that might be used to edit the host machine's registry. Besides this, we can also see things like these strings where it says you should have administrators right in order to activate a higher level version. This could be a sign that the malware requires administrative rights to run certain processes, and also shows that it might be trying to perform escalation of privilege by asking the user to type in their credentials. Lastly, the other important strings that we found are strings such as deactivate account CTX, activate release, and create account CTX. An activation context is a data structure in memory containing information that the system can use to redirect an application to load a particular DLL version. So this might be used by the malware to tamper with the activation context so that certain things can't be run in the memory. Now the next and last thing we'll be using for our basic static malware analysis is PE Studio. As we can see here while the indicators are loading, give it a while. Okay, while the indicators are loading, we can take a look at other stuff such as things like the resources, the strings. As you can see, these are the different registries that might be affected by the malware. Over here we can see the imported libraries, the different DLLs used at the bottom, as well as some imported symbols. Okay, now that the indicators have loaded, the noteworthy indicators here will be things like the count 177 of imported blacklisted functions has reached maximum thresholds. This shows that there are 177 imported blacklisted functions, which means that these are the common things found in malware that the PE Studio has found. Besides that, there are also things like this file modifies window registries, which shows that window registry is being modified by the malware when it's run. Other stuff like this malware creates and modifies files, and this file interacts with event log, as well as the file changes the protection of the virtual address space. These are the other things that are important that we can find using PE Studio. So in summary, after performing our static analysis on the malware, we have concluded that this malware is a known malware made in 2018, as well as that it has been packed using UPX to make it harder to analyze. On top of that, we have also seen that it can modify things like Windows registry. It may be impersonating the user's permission, and that it is a type of ransomware that has the capability of encrypting your data. However, it only works on certain OS such as Windows XP and Windows 2003, Windows NT, whatever. So next we'll be performing basic dynamic analysis. Now the first thing we'll be doing in static dynamic malware analysis, we'll be running the malware and seeing what it does. So over here, we'll double click on our malware, run anyway, and wait for it to load. And we'll give it some time to load. Now as we can see, after waiting a while, a pop-up has appeared from the malware scare ransomware upx.exe asking for administrator password. So we'll give it to him and let it run for a while more. Now as we can see, after giving it some time to run, the malware has disappeared from our desktop, and certain weird stuff like this notepad document here has appeared in our hard disk. Opening up the contents is mainly gibberish, but we can see certain things like https blockchain info directory, https local bitcoins, mastercard, visa, etc. So we can assume that this is the message used by the ransomware to tell the victim who has run this ransomware on the proper OS to visit this website and to pay out the money so that they can get their computer rid so that they can get rid of the virus on their computer. When we open up this directory in another web browser, now to see the modification that the malware will make when we run it, you'll be using this tool called what changed. First, the first thing we'll do with what changed is scan the files in the C and D drive as well as the registry in current user to get a baseline first. Now we'll only be scanning these few things right now so that we can save time for this demo, as scanning everything will take too long. So in order to do this, we'll first get a baseline stat. Right now it's currently loading to get the baseline. And then we'll run the malware. Let it run. And then we'll finally proceed to click on step 2 and find out what has changed. Okay, now that our what changed is finally completed, you can see the different files and the different files in the C and D drive that had changed, as well as the registry changes made in the current user. As we can see here, these are the directories that has modification applied to it. The important things here are this thing right here, add data roaming osk.exe file. So if we head to that location under C drive, user, matt, app data, which in order to view it, we'll select hidden item, roaming. We can see a new file called osk has been made. Now that we got our VM up and running again via the last snapshot, we'll now be using Process Monitor, Process Explorer, and Wireshark to see what possible changes the malware might be doing. So before we open up the malware, we'll start Wireshark, and now we'll run the malware. Run anyway. As you can see in Process Explorer, our malware is currently running, as you can see right here. Now looking at our Wireshark to see for any outgoing transmission, we can see certain transmission like this TCP, this few TCP here. Oh, now the pop-up has arrived again. We'll put in our credentials and let it run. So as we can see from Wireshark, there isn't really that many important outgoing traffic that the malware is making besides a few TCP connections which leads to nowhere. So we'll close the Wireshark. Now looking at Process Explorer, you can see that osk.exe is now running, and the initial malware Scarab ransomware is now gone. And from what we know from previously using what changed, we know that osk.execute is the new file that the malware created. So we can conclude that the malware deleted its original file to hide it in osk.exe so that the user will have a harder time finding where it is. As we can see right there, I didn't close Process Explorer. Process Explorer closed on itself because of the malware. So the malware, as we know, is a ransomware that changes that modifies certain files and programs in the host OS. So because this is not a fully compatible version of Windows that the malware can run on, it's only able to like affect certain applications such as Process Explorer but not others. As we can see, our Process Monitor is still running. So if we try to open up the Process Explorer again, give me a moment. You can see that now when I try to open it up again, it isn't able to open. Like it is not opening. And this is because of the malware. See, when it open right now, it closes immediately after. So now we'll take a look at the registry changes made by the malware using Process Monitor. When you scroll down Process Monitor, you can see all the Scarab ransomware, all the different registry keys that it does. So as we can see here, it does many of the same functions like create file, close file, query, and registry key close, open, registry enumerate. It perform many of the same processes many times and many different directories as we can see here. So it keeps doing the same thing at different directory. So as we know, ransomware, the main purpose of it is to encrypt files, to encrypt every files on the user host system so that the user is unable to access any of his applications and files. So as we can see here, what the ransomware is doing to our computer is changing the registry key and certain file things in every file of every directory, and it's repeating this same process many and many and many times until it reaches every single file in every single directory. Same thing with the osk.executable file that is also running on our computer. Yeah. And with that, we've come to the end of our basic dynamic malware analysis. So through our basic dynamic malware analysis, we have come to the conclusion that our malware modifies many of the registry key in every file like a ransomware would. This can be seen from Process Monitor, as well as the fact that our change documents were modified to something else as well. Now, to remove our malware, we'll be using malware bytes. So in malware bytes premium trial, we'll be clicking on scan in scanner and wait for it to scan and detect the malware. Now that our malware scanner has finally finished scanning, we can see that it has managed to scan the ransom scarab in our system. So to remove it, we will click on quarantine and it will remove the malware. Now that it's done quarantining and deleting all the malware, as we can see here, the malware is now gone. And with that, I've come to a conclusion of my assignment, my MATT assignment, static malware and dynamic malware analysis. Thank you.